Final 2002 robot with our group Don Bork here, Ethan, and me killed this robot. So we've got on the back we've got LED switches or LEDs to show the state of the robot. So right now it's waiting for a state. If we turn on power, changes to a different animation. We disable planetaries, has a different animation. It's all controlled with this Arduino over here running the 2-bit parallel data communication right there, as well as the 8 LEDs right here in common anode configuration. So on the front here, we've got the beautiful purple actuation on there. Force feedback. You also notice we have a limit switch or a line sensor. Controls the forward and backward. Turn it on, disable it, does whatever, retracts back in there so we can drive up and down the board. These little feet right here. In terms of actuation in there, we've got a linear drive as well as a linear pot in there measuring the force.
I thought it was
compression of springs there.
If it was, that'd be very
Take the top off.
I was so impressed. Like, really, that's what they're doing on 1001. I feel like I didn't know.
See the springs compressed there, trying to provide the optimal force.
The only thing I don't like about these courses is like you have to destroy the lower end.
Force driving back. Also got a backwards limit switch on there in case we try to drive past our mark, so we turn it off and don't stall out our motors. Going around on the back, some of the circuitry we've got here. Got our nifty little hook. So on the back we've got 2 Arduinos running in parallel. We've got the wires for the linear pot right there. Also got debouncing. That's communication network wiring right there on the top right. And then the little little yellows are capacitors. This the analog filtering for switch debouncing. It's feeding into the Schmidt trigger, which is the IC, long IC on the left. Got a negative supply rail for the op amp MC1458 because they had a 2-volt DC offset that we had to correct to get the optimal values for the op amps. Op amps are down on this end here. You can see the little 1 microfarad capacitor out there as well. Doing level shifting on that. We have about a 1.23 gain of the op amp there to bump the signal up a little bit. Also a break frequency of 40 Hertz to get rid of any unwanted noise from 60 Hertz lights as well. Also only have 1 battery on the robot, so we have a Y connector we custom built right here. Heat shrink on there running to the 2 Arduinos. And that, the RBE2002 project, worked really well and force control really well.